Good afternoon, everyone. My name is Jeremiah Dooley. I'm one of the principal architects at SolidFire, and I want to welcome everybody to our ongoing webinar series, this one around accelerating your OpenStack deployment. Just a couple housekeeping items real quick. I have Jen Hansen here with me, and she's going to hang out in the background and take all of your live audience messages down at the bottom. So if you have any questions as we go through the presentation, please feel free to enter those down in the bottom and submit them. And as Jen gets them, she will interject and drop them into the conversation, or depending on how things go, we may save them up until the end. But please feel free to put anything you want to in there, and we will attempt to answer as many of them as we possibly can. We're going to keep this pretty interactive. We've got some voting to do around the state of your OpenStack deployment and where you see OpenStack. But again, any questions, any comments about the presentation, or any anecdotes about your own experiences with OpenStack, please feel free to go ahead and put them in the message box down at the bottom. And with that, we will go ahead and get started. So, like I said, my name is Jeremiah Dooley. I'm a principal architect here at SolidFire. I've been with the company about a year and a half at this point. And prior to SolidFire, spent 3 years with VCE in the office of the CTO. So converged infrastructure and how it is that we make IT easier to reproduce and easier to get out of the way of the workloads that we're supporting is pretty much something that I do full-time here. My Twitter handle is down at the bottom. If any of you want to follow up or ask questions on Twitter or just join the conversation, please feel free to join me. We're going to talk today about OpenStack and OpenStack deployments, and we're going to put it in the context of storage in general and Cinder storage in particular underneath OpenStack, but we're really going to talk about what we see enterprise customers doing with OpenStack and some of the challenges that they're running into. Like I said, we do have some audience polling questions so that we can see where everybody is, and I figured starting off with one of those here at the beginning would probably be the best way to go. So if you see it come up, Jen, you can go ahead and throw the first polling question up. The first question for the audience is, in production today, which is your primary hypervisor? And we've got a couple examples up there of VMware vSphere, KVM, Microsoft Hyper-V, Zen and Zen Server, or you're not virtualizing anything and you're not real sure exactly what a hypervisor is. So take a second and go ahead and put your answers in, and after we get a few votes in there, we'll go ahead and view the results and then continue on to the next part of the presentation. All right, Jen, if you want to go ahead and stop the voting on that one, we will go ahead and view the results. And it looks like primarily people are using vSphere in production, and this is pretty common, particularly with enterprises. The vast majority of the workloads that we see today are running on vSphere. That there's some KVM and some Zen thrown in there, particularly around an OpenStack topic, not surprising. So pretty typical of the webinars that we do and of the customers that we talk to. vSphere still has the lion's share in the data center, but we're starting to see more of that transition over into KVM and Zen. So let's start just with a general topic around why are OpenStack deployments slow. Depending on who you ask, either the enterprise adoption of OpenStack is increasing but slower than expected, or the enterprise adoption of OpenStack is slower than than it should be. And so when we look at all of our customers, what is it that we see from them around why those OpenStack deployments are slow? And what we get from them are both good answers and bad answers, right? The good answers are ones where you can tell that the that the customers really started looking at OpenStack in the right way. They're really starting to try to figure out what it is that they have and how they're going to do it. And some of the good reasons that those deployments are slow are just that it's new. New technologies, new skill sets. You're responding to a new consumption model, and consumption models inside enterprises are tricky because it's not just a new way of presenting resources to them, it's generally a new audience that you're presenting the resources to. Most enterprise IT organizations have gotten really good at provisioning VMs for enterprise workloads. So provisioning out compute resources and storage resources to developer teams, there's a transition. There's an understandable transition in how it is that gets positioned and how that gets rolled out. Workload availability is important, and that means the risk of it is pretty high. There are good alternatives, so having things be slow just because you're worried about the workload is certainly a good reason. And transformation in general, particularly inside some very siloed orgs, is just really hard to do. On the bad side, we hear customers say, well, OpenStack is unstable, it's too complex, we don't have the right kind of staff, it's too new. These are answers that may have been valid 18 to 24 months ago, but largely these answers are in the rearview mirror most of the customers that we talk to from the enterprise side of things. And if we look at that holistically, what are we seeing in the field today? About 40% of the pipeline of our company, of SolidFire, has, across both the service providers and enterprise customer bases, is OpenStack related. And that number continually increases over time, where we see that enterprises may still be using vSphere, right? They may still be, and we'll talk about it a little bit later on, they may still be using vSphere and OpenStack at the same time, but the number of projects they have that are attached to OpenStack continues to increase. The OpenStack ecosystem itself has come a really long way, and we kind of, mostly tongue-in-cheek, split the OpenStack ecosystem into the real ecosystem, those being code contributors, project leaders, champions, people who are really giving back to that community as part of their investment in and belonging to the OpenStack community. And then there's, the people who have to be in there, the hardware vendors who need to be able to sell their stuff to people who are using OpenStack, but who are largely contributing the ability to consume their products, not necessarily anything meaningful or intellectual property related back into the OpenStack environment. What we also see is that the deployment process is so much better than it used to be. When we look back 2 years and you see companies like Nebula and you see companies that are really trying to over-engineer OpenStack deployments to be easier, we really don't have a need for that anymore. You can find any number of primers on how to deploy OpenStack onto your laptop, in a virtual box in less than an hour, right? Get it up and running, test it, play around with it. One of the reference architectures that we'll talk about is it shows and provides all of the scripts for getting a full Red Hat OpenStack environment up and running from bare metal in less than an hour. So the deployment process is so much better than it used to be, and that really makes the entire adoption model easier. And enterprises are seriously working out how to integrate OpenStack. What's interesting is it's not just from a software standpoint. It's not how do I install this, or what does it do, or how do I customize it. It's operationally, how do I deliver on this consumption model? How do I manage the ticketing? How do I manage the maintenance? How do I manage the customer base that I'm providing these resources to? And when we start to see serious thought being put into the operational standpoint of OpenStack, that's when, from our perspective, we think that things are really starting to move forward. So certainly good to see. When we talk to our customers and we ask them, if you want to accelerate your OpenStack deployment, what are the things that you need? The first is understanding that operational impact of OpenStack. For many of the customers that we talk to, the idea of working with developers, the idea of putting in place a DevOps operational model, all of these are new things. They don't understand what's being consumed or what it's being used for. And so there's a lot of help that we can give them around what is it that they need to know, who is it that they need to talk to, what are the bridges that they need to build in order to be able to take care of that part of their constituency, as well as they've taken care of the part of the enterprise who just wanted a VM provision so that they could load an application on it. The second one is understanding which workloads go where. We'll talk about it a little bit later, but OpenStack is not a VMware replacement. I think that there was a notion early on that in order to avoid VMware licensing, you could simply deploy OpenStack and move everything over. And as we've, as that ecosystem, as that market has matured, it's become real apparent that there are workloads that absolutely belong on a hypervisor like vSphere, and there are workloads that are very conducive to being deployed through OpenStack. And so companies need help deciding which workloads are best suited for which, and how is it that they can get them from one place to the other, and how do the operations change, how does the reliability and performance change, and then finally examples of what works and what doesn't. Right, the real world examples, the battle scars that companies have gone through, those are the things that customers really want us to be able to kind of collect up, publish the best of, and help them figure out how to get into an OpenStack environment as fast as possible. In almost every instance, storage ends up being a huge question mark, not just because it's critical to the success of the platform, but also because OpenStack introduces some additional storage topics, that being image storage, that being object storage, that are new to a lot of enterprises that are coming out of a pure VMware background where we just present block or NFS storage up, and create data stores out of them. So when customers look at the things that they need, help simplifying storage is almost always on that list. So let's get started. We're going to do a couple things. We'll go through a quick overview of the SolidFire storage solution. I promise I've cut it way, way down. We'll try to get through this part as quick as we can. What I really want to talk about are some of the things that are specifically useful in an OpenStack environment and some of the differentiators that SolidFire has that help make deploying those OpenStack environments that much easier. We'll go through some details on the SolidFire Cinder driver capabilities. We're pretty proud of the work that we've done with the OpenStack Foundation and with the amount of investment that we've made there. And so showing you some of the things that our Cinder driver can do, I think will prepare you to be able to ask other vendors what is it that they're investing and what sort of capabilities are they going to be able to have. We'll go through an overview of the Agile Infrastructure reference designs. How do we take all of those things that we've learned and all of those design criteria that we see enterprises have and package them up and make them easy for you to consume. And then we'll finish up with best practices and lessons learned, and then we'll take some questions afterwards. So I don't see any questions in the queue, so we'll go ahead and get started. So for the next one here, what we're going to do is we're going to do the second of the poll questions. Jen, if you want to go ahead and launch that one out live. The question here is, what stage are you at with your OpenStack deployment? And this is really just to get a sense of how many of you are looking at it with wide open eyes, never having jumped into it before, or how many of you are currently using it in production and are looking to find better performance or find more efficient operations or refine the implementation that you have. So we've got a number of ranges there, but go ahead and cast your votes, and we'll give it a couple seconds here to make sure that we get as many people voting as we can. There we go. Always makes me nervous when I see that we've got 50 people watching the webinar and 4 people who have voted. So go ahead, real quick, pick where you are with the OpenStack deployment. Give it a couple seconds, and we'll view the results. All right, 10 more seconds. All right, if you want to go ahead and stop the voting on that, Jen, we will look at the results. Considering OpenStack for my cloud. Good. I'm actually really encouraged with the number of people who are currently testing and currently using OpenStack in production. Every time we've done this, I think this is our third or fourth one that we've done here over the last 14 months or so, and those numbers continually creep up, which is good. Like I said, I think if we look anecdotally at the number of customers that we're talking to, we certainly see that momentum. It's good to see it in the in the audiences that we're talking to as well. So excellent. Excellent. All right. So if we continue on here, let's talk about SolidFire for just a minute. SolidFire is a high-performance all-flash storage system, which is specifically designed for environments that need both scale and predictability. So it's a scale-out architecture. They're individual shared nothing nodes that collectively together form a storage cluster, and they can range in size from 4 nodes up to 100 nodes, which means anything from 35 terabytes to 3.4 petabytes of capacity. These are designed to scale linearly, and we'll talk about that here in a second. But outside of just the hardware, what there really is are a rich set of data services that exist there, particularly around how is it that we scale and protect data, and then how is it that we partition out the capacity and performance in ways that help make those applications run better and run better together. So if we think about all flash arrays, again, we've got the performance and capacity, and the question is, how do we take that and turn it to bear on the workloads that we're seeing? Every decision that we've made about the storage product has been with these 5 operational pillars in mind, right? That the scale out portion of the platform, how we scale out, how we protect data is very important. How we protect that data and the high availability there, the quality of service, which we'll talk about, the complete system automation, which we'll talk about, and then the inline data reduction. We tend to stay very focused on the things that are important to our customers, and those align generally around these 5 pillars. We're only going to dig into 2 of them, however, because from an OpenStack standpoint, there are some things that are more important than others when it comes to this type of environment. So first, let's talk about scale out. Like we talked about, from a cluster standpoint, we can start with as few as 4 nodes. In this case, we're using nodes that provide roughly 50,000 IOPS per node. So when we have that original cluster, what we've got is 35 terabytes of capacity. We've got 200,000 IOPS, right? If we want to increase either the capacity or the performance of this cluster, rather than having to forklift from one pair of controllers to another, rather than have to buy a new array and migrate data over, all we have to do is buy a new node. And when we put that new node in place, we're going to linearly scale out both the capacity and the performance based on the node that we put in place. So both the performance and capacity is there, and this goes in both directions. So we can expand clusters as we add nodes. We can also shrink clusters as we need to pull nodes off. So we have customers who will build out clusters and then split them in half and distribute them into different parts of the data center. We've got customers who will have multiple clusters and multiple facilities, and we'll pull one node out of each of them to populate a new facility. The idea here is that we're going to guarantee the compatibility between all the nodes. So no matter what node of what size or what performance, it's always going to be able to work inside an existing SolidFire cluster. So these nodes that you expand out don't have to be similar. You can have nodes with more capacity than performance. You can have nodes with more performance than capacity. You're never going to have to wait 3 years for an upgrade. I mean, particularly in the flash world, right? We get better pricing on flash disks, every 6 months. The price point for the capacity that you're looking for comes down, and we're able to pass that directly on to customers in real time. It also means you don't have to buy more than you need. So you buy exactly what it is that you need, and you increment that up in stair steps that make sense to your consumption rate, to the workloads that you're using. We don't want your consumption to be dictated by our architecture. We want it to be dictated by your workloads and by the business that you're doing. So now that we've got these pools, right, we've got this great big huge, dozen node cluster that has all of this capacity and performance. Now we need to figure out how is it that we protect the workloads that are running in there. Because if you think of a traditional storage array, if I give you a great big pool of capacity and performance, and I put in there a very, very noisy application, right? Maybe that's a VDI implementation, maybe that's a series of databases, maybe that's a backup platform. I'm going to be able to crush everything else that's on that array, no matter how big it is, with an application that really needs the performance, particularly on the I/O side. So one of the things that SolidFire built into the core of the platform is the idea of guaranteed quality of service. If you look at the screenshot that's there, this is the create new volume interface. And every time you create a volume, we need to have 4 pieces of information. We need to have the total size of the volume, so we need to have the capacity, and we also need to define the minimum, the maximum, and the burst amount of I/O for every volume that goes in. So when this volume gets provisioned, we know exactly how much of the pool of capacity and how much of the pool of performance we're going to be able to allocate for that specific volume. Right? So what does that look like? If we take, in this case, a 5-node SolidFire cluster, we haven't provisioned any volumes on it. We see that each node provides us 17 terabytes of capacity and 50,000 IOPS. Each of these gets virtualized out into a pool. So you can see on the right-hand side, we've got 60 terabytes of capacity available, and we've got 200,000 IOPS available. And now, as I go through and provision volumes, all I'm doing is taking the amount of capacity and performance that I need out of those pools and allocating it to a specific volume. When I allocate another volume, I pull more out. I allocate another volume, I pull more out. When I want to put more performance or more capacity back into the pools, I simply add another node in. The idea is that we can take 2 resources, that being capacity and performance, that have traditionally been tied together, right? In a traditional spinning array, every spindle has a certain amount of IOPS. And whatever the capacity of that spindle is, it is inextricably tied to the IOPS that's in there. Being able to break those apart gives us many of the same benefits that we got out of being able to break CPU and RAM apart, despite the fact that both of them come inside the same 1U servers that we've been virtualizing for the last few years. If we can take storage and provide resource management for it the same way that VMware did for CPU and RAM, then we've created something that's really powerful and easy to use from a virtualization standpoint. Now, if we provision these out separately, the question is, how does QoS end up protecting them? In this case, we've got a volume. That volume has a burst I/O of 2,000 IOPS, meaning no matter how much that workload that's using that volume wants to be able to consume, it'll never be able to consume more than 2,000 IOPS. It'll max out at 1,000, and it'll have a minimum of 100. So no matter what's happening on the rest of the array, no matter how busy it is or how many applications we have running, this volume is always going to be able to get a minimum of 100 IOPS. And when we look at what that looks like, you can see the min, the max, and the burst. And you can see that during normal state, it'll run right up to its max and stay there. And then when it comes down, we'll let that volume earn burst credits. It's behaved for a while, so we'll give it the ability to spike up to its burst point. And then after the spiking finishes, it comes back down to the max. And we're going to enforce that all the time on every volume, no matter what the capacity of the array is, no matter how much is available, no matter how much has been used. And we're going to do this not just for one volume, but we're going to do this for every volume, no matter how many there are on the array. And each of these can have custom settings. So we can have one that has a minimum of 100 and a maximum of 500. We could have another volume that has a minimum of 1,000 with a max of 1,500. We could have a third volume. All of these, regardless of the I/O patterns, regardless if one is Oracle databases, one is a test dev environment, one is a VDI deployment, every one of these volumes is always going to have its QoS respected, regardless of how busy the platform is. So now we've done 2 things together that make for a really unique experience on the storage side. We've allowed you to provision the capacity and performance separately, and then we've guaranteed both the capacity and the performance on a per volume basis. So now that we've given you the capacity and performance to be able to carve up, the question becomes, how can we make this easier to operate? You've got a single array, you've got lots of capacity and performance, you've got a lot of volumes. In the case of OpenStack, every instance that gets deployed has independent volumes, right? So you could have, thousands or tens of thousands of volumes on a single array. How is it that we're going to help you be able to manage this? And the answer is that the platform was built first and foremost around an API. The SolidFire API is native. It is 100% feature functional, meaning everything that we do, whether we do it with the UI, whether we do it with an OpenStack Cinder integration, whether we do it with a VMware vCenter integration, everything is run through an API. So even our own GUI is going to use the API that sits underneath it. There's nothing that gets done in any part of the operation of the storage array that doesn't end up going through the API. So everything's public, everything's wide open. You have the ability to orchestrate it, to automate it, or to use the tools that you want to with it. Being able to do this, being able to, you can see on the left there, the Create Volume API, really allows us to do some fun stuff with the integrations of the platform. Whether those are tools, so PowerShell and software development kits, whether those are interfaces, our user interface, or the ActiveIQ cloud monitoring software that we include free with every array, whether that's plugins, CloudStack, OpenStack, VMware, or whether that's custom integration, that you have a self-service portal that you want to be able to integrate in, that you have homegrown apps that are going to be able to either report against or provision against the storage array directly. The API is there to be able to facilitate all of that. And when we look at it from a big picture, there are these storage system tasks, right? These are, for those of you that have been in storage as long as I do, these all look really familiar, right? These are the things that you're going to do every day as a storage administrator, right? Whether that's drive quantities and ratios, whether that's drive types, whether that's RAID types and RAID groups and stripe sizes and snapshot growth limits and all of the things that you have to take into account when you're operating a storage array. Because everything is pooled, because everything is a single cluster, and because everything is driven directly through the API, SolidFire has the ability to really scale back the number of things that a storage operator has to worry about, right? And we're going to make those pretty straightforward. From a SolidFire standpoint, you need to be able to do the initial size, both capacity and performance of the volumes, right? You need to be able to create accounts so you can provide multi-tenancy or provide roles-based administration to the box. And from a scaling standpoint, you need to know how much capacity and performance you're going to need going forward. And that's it. Everything else on the back end, how the disks are laid out, balancing load across the array, all of that is handled by the system and by the APIs on the back end. That level of automated management really drives down the amount of effort that goes into maintaining the storage and allows you to focus on the applications that are consuming the storage. So no more performance tuning, no more tiering or prioritization, no more RAID groups, no more spare drive management, no more fire drills to replace failed disks, failed controllers, no more running at n+0 because you had a controller fail and you're waiting for a vendor to show up. No more generational or forklift upgrades. We want to take all of this off the table, not because we've got a services org that can do it for you or we've got a partner that can come help you with it. We want to take it off the table because that's the way the architecture was built. And then we want to make sure that we put our money where our mouth is. And the two things that we're going to promise customers are that the platform will always be compatible. Every future node that we release, and we are now on our 3rd generation of hardware and our 8th generation of the storage OS, every future hardware and software platform that we deliver will be backwards compatible with every existing infrastructure. We're never going to provide a product and then say, oh, we're sorry, this won't work with the existing investment that you've already made. You're going to have to buy something new. At any point when you come to SolidFire and say, I need a new node, we put that node in place, whatever size and performance of the node, and whichever generation of hardware or software it is, it will always work with the existing investment that you've made. And then the second is, we're frankly tired of talking about driveware. So we put a complete 100% guarantee around all flash driveware concerns. So no restriction on use case or workload, no special support contract needed. If the driveware gets below acceptable levels, we'll replace the drive free of charge for any array under a support contract for the life of the array. We really want to make sure that what we're focusing on is how do we make the storage better and how do we help you operate the storage better, and not about trivial things like promising that we're not going to abuse the investment that our customers have already made in our platform. All right, so that brings us at the end of the SolidFire section to audience polling question number 3. And if you want to go ahead and make that one live, Jen, we will give everybody a couple minutes to answer. The question here is, which block storage driver would you look to integrate with your OpenStack deployment? The voting will only allow you to select one. So if you look through the list there, Ceph, EMC, NetApp, 3PAR, SolidFire, go ahead and pick which one of those you're currently using or which one of those you're evaluating in your OpenStack deployment. I like that we're getting more votes as we go along. So again, which block storage driver would you look to integrate with your OpenStack deployment? We've got some common ones up there: Ceph, EMC, NetApp, 3PAR, and the best of all of them, SolidFire. Give it about 10 more seconds. Go ahead and get a vote in real quick and we'll look at the results. About 5 more seconds. All right, Jen, go ahead and close that one down and we'll take a look at the results. Oh, good. Spread out pretty well. Ceph and EMC and NetApp up at the top, and then 3PAR and SolidFire down there. Okay, good. Ceph is an interesting one. I think when we get to the lessons learned, we'll talk a little bit about what we've seen from customers that have tried Ceph. But pretty representative of the clout of some of those. I mean, Ceph obviously with Red Hat and the work that they've done there since acquiring Inktank, and then EMC and NetApp as the elephants in the room. Pretty typical of what it is that we see. So thank you for your votes. So what does SolidFire look like in an OpenStack environment? Pretty unequivocally, we'll say that SolidFire is the best block storage on the planet from an OpenStack, from a Cinder driver perspective. And part of this is just the investment that we've made. A few years back, when the Nova Compute included both the compute and the storage side, some of the SolidFire guys, particularly John Griffith, who was the project team lead there for a number of years, spearheaded the project to break block storage out of the compute side of things, and really spearheaded the beginnings of what we now know as the Cinder project. Our investment there is, we're a storage company, but our investment there is very proactive and real-time, not necessarily reactive after we release a product. So when we talk about being compatible with Cinder or having a valid Cinder driver, those are first-class citizens for us. When we, when OpenStack releases a new version, there is a SolidFire Cinder driver that is native, that is upstream, that is included in every OpenStack distro that comes off of the, off of the source, the source code based from the Federation. So it's a very real investment for us, both from a community standpoint as well as from a code standpoint. And what we wanted to do was make sure that there were some things that were very clearly taken care of. The first is that our Cinder driver will enable every OpenStack block storage feature. If there is a block storage feature in OpenStack, it will be integrated into and be available through the SolidFire Cinder driver. We wanted also on top of that to be able to bring some of the differentiation that SolidFire has into OpenStack, particularly the ability to set and maintain QoS levels on a per volume basis. And in OpenStack, for those of you that have used it, that means on a per instance basis. Every time you deploy an instance, the volumes that go with it, there's a QoS value that's passed down to that in real time through the Horizon GUI every time you deploy an instance. So QoS from a SolidFire perspective is pushed down into every instance that gets deployed in OpenStack. We wanted to be able to snap, create clones, and manage volumes directly from within Horizon so that customers don't necessarily have to have two windows open, one with the Horizon dashboard and one with the SolidFire dashboard. We wanted to be able to run OpenStack instances on a SolidFire volume, so create bootable volumes. And we wanted to be able to make all of that as automated as possible. We wanted to get as many of the management layers between OpenStack and the storage system automated as we could so that there's no manual intervention that needs to happen there. There's no additional features. There's no licenses that are required. It takes a grand total of 3 lines of code to configure a SolidFire storage array with OpenStack Cinder driver. And doing so gives you, full multi-tenancy account creators. Project owners become SolidFire accounts so that you can track who's creating volumes and who's using capacity. We've validated that interoperability with Rackspace and Red Hat and Mirantis. We've done a lot of really interesting work with the Platform 9 guys. I'm interested to see how that relationship goes over time. And we've had some great customer successes. The logos that are up there are the ones that you probably would recognize, but on both the enterprise and the service provider side, the number of customers that are using SolidFire to provide their Cinder block storage backend continues to grow. And we attribute that to both our involvement in the OpenStack community, but also with the features and the functionality that we're putting into that driver by default. So how do we take the SolidFire storage array, the Cinder integration that we've done, and what it is that we're being asked for by enterprises on how to build and run OpenStack private clouds, and how do we package that up and make it easily consumable? For us, that is a product that we call Agile Infrastructure. And Agile Infrastructure is a reference architecture program that is designed to be modular at every level. It's designed to be both OpenStack and VMware, but the idea is that we want to accelerate how quickly customers can get infrastructure into production. We don't want to limit them. We don't necessarily care which vendors' hardware it is that you use, but what we want to be able to help you do is build an IT as a service consumption model as quickly and easily as possible without asking you to reinvent the wheel every time we go through that. So what does it look like? Like I said, these are for both OpenStack and VMware. We've done reference designs with both Dell and Cisco hardware. We've used Red Hat distributions. From a distribution standpoint, SolidFire certainly doesn't care. As long as it's got a valid Cinder implementation, we're going to work with it just fine. So whether it's Red Hat, whether it's Ubuntu, whether it's Mirantis, whoever it is that's putting out the distribution is going to work just great with the SolidFire side. And what we wanted to do was break it out so that we look at the applications, we look at the orchestration layer, we look at the cloud management stack, and then we look at the bits and pieces, the compute and networking, the logical configuration diagrams, the network configuration that sits underneath it, all of that sitting on top of the SolidFire storage array. Operationally, what we wanted to drive with AI was some things that are questions that came directly from customers, right? How do I take the concept of pooling capacity and performance and turning it into resources that can be consumed through OpenStack? How do I get from bare metal to OS and how do I configure and install OpenStack in a hands-off manner with bare metal provisioning so that I can rack and stack hardware and it will get brought into my OpenStack resource pools as fast as possible. How do I linearly scale not just the compute and storage nodes, but the networks that sit behind them as well? How do I maintain consistent performance? And then how do I be as efficient as possible with both the storage, but also with the, the footprint of the entire platform? And we've got a total of 4 of these now, and each of them we're really trying to stay focused on these workloads. We'll talk about that a little bit here in a minute. For OpenStack, what we built was a logical framework. We wanted to talk about what are the components, but we didn't want to necessarily lock anything out. There are some people who are very comfortable with neutron networking. There are some people who are very insistent on staying with Nova networking. Our job isn't necessarily to make the choice one way or the other. It's to help facilitate whichever direction a customer wants to go. So we wanted to make this modular at every level. We wanted to build it both on the vendor best practices, but also on our involvement in the community and our involvement with the enterprises that are consuming and using OpenStack today. And then we wanted to provide as much integration as we could for the management stack. So when we look at the dashboards or custom tools or monitoring tools or continuous integration modules, we wanted to be able to make that as easy as possible to tie into, and then have as much support as we could for the tools that customers are using today. We point this one out just because it's a pretty constant source of questions from customers, is around in a full production OpenStack environment, we've got a bunch of different networks, right? We've got the storage nodes which have networks, but we've also got the compute nodes and the controller nodes and the provisioning servers, the bare metal provisioning servers, and all of them have separate networks that have different requirements for what they need to talk to and what level of security they need to have on them. So as part of these reference architectures, we've done it with both neutron networking and Nova networking, but being very clear around what does that network topology look like and what are the best practices and what are the switch configs, regardless of the switches that you're using, in order to be able to implement those networks so that you can segment out the OpenStack networks in much the same way that you would have segmented out the VMware networks with vSwitches or with distributed vSwitches. So really being able to bring some clarity into the things that are sometimes less than transparent on the OpenStack side was something we wanted to put a lot of focus on. And that goes not just with the configuration, but also with the scalability. In this case, what we want to be able to do is scale not just the storage. We know how to do that. That's pretty easy. We add nodes. It rebalances. Everything works the way it's supposed to. But how do we add OpenStack nodes? How do we add upstream bandwidth? How do we add additional racks? How do we add additional data centers? And how do those data centers talk to one another? Being able to provide a full network topology across multiple racks or multiple data centers is something that we get asked for pretty often. But really, at the end of the day, what we wanted to focus on was the use case. Putting things together is great, but only in so much as it supports the use cases and the workloads that our customers are using. So for the reference architecture, we really wanted to focus on some sample use cases. Life cycle, software development life cycle, large-scale web applications, persistent block storage, databases, the things that customers are actually using OpenStack for. And if we look through these, we very clearly and deliberately laid out what it was that we tested and how we tested it so that it is as useful as it can be to customers. Some of those are basic things. Red Hat provides a certification test suite. Tempest, obviously, on the OpenStack side, provides a test suite to say, is everything configured and working properly? But then we wanted to do some fun stuff, like can we provision from bare metal to operating system on all 17 nodes within 30 minutes? Can we install and configure OpenStack on all 17 nodes in less than 30 minutes? Can we scale not just the block storage, but the compute instances? Can we dynamically add those into running environments? And then just some resource agility tests. How long would it take to deploy this many instances? How long would it take to delete this many instances? How long would it take to boot those up? Those are things that customers are looking at in real time and are asking questions about. And so we wanted to make sure to exhaustively document it. How do we preserve quality of service? how do we take the awesome quality of service powers that the storage array has, how do we make those transparently and easily available into OpenStack, and how do we do that dynamically? So how do we take a bunch of different applications, run them in parallel on the same storage array with different types of QoS levels? So in this case, you can see in the box there, we did a low IOPS, a medium IOPS, and a high IOPS. But how do we allow users to specify which IOPS bucket gets assigned, or which IOPS level gets assigned to their volume? And then how do we let customers change that? So if I've got a workload that's going from test into production, and I need to be able to triple the amount of IOPS that it can do now that it's in wide use, how do I do that dynamically? How do I do that directly through OpenStack without having to go in and migrate data or move things around on the storage array side? From a best practices standpoint, we see customers who've been really successful with OpenStack. We also see customers that have been less than successful with OpenStack. And sometimes that's a workload issue, sometimes that's an internal politics issue. But when we look at the best practices and the lessons learned, there were some things that stood out that we really wanted to share with the group. Number one is really understand what you want to accomplish. For some companies, OpenStack is a corporate mandate. We're not going to use Amazon Web Services for this test dev anymore, and all of it needs to be moved internally. We want to keep the same consumption model. We're going to go OpenStack. For some companies, it's a cost-saving measure. For some companies, it's a resource utilization or a workload migration effort. But really understand what it is that you want OpenStack to accomplish in your environment and map out how it is that you're going to get there. You can't accidentally get benefit out of putting OpenStack on the floor. Making sure that you know what you want to get out of it and how it is that you expect OpenStack to impact that gives you the ability to really start to stage through the things that you want to be able to do. The second one, obviously, the storage choices are complex and critical. This is one of the places where we really start to see customers running into issues with Ceph. Red Hat is a great friend of the family. We know that they've gone all in with Ceph and saying that for block, file, and object that Ceph is the way to go. And on the object and file side, we've certainly seen customers have lots of success with Ceph. On the block side, pretty quickly you run into the limits of what that file system is capable of doing. You run into limits with how does it behave during failures. You run into limits with how scalable can it be. We did a pretty exhaustive white paper that is available to anybody who wants to ask for it around the comparisons between, what does Ceph look like actually running right directly on a SolidFire node. So same node, same 10 SSDs, Ceph on it, 4 nodes in a cluster versus same node, Element OS running on it, SolidFire cluster. There's just limits to what it can do. And so we've seen lots of customers who've put their toes into Ceph and said, I'm going to be different. I know where the limitations are. I can get around it. I'm going to be a special unicorn. And then 6 months later, they come back and say, it worked great in test dev, but there's no way we can go into production with it. Let's talk about what we can do with SolidFire to help fix those problems. So the storage choices are complex. There's lots of things to think about. They're also critical to the success, particularly as you start to take a limited pilot environment and start to push it to a wider audience. The distros is another interesting part. If we look at even just take 3, take Red Hat, take Ubuntu, and take Mirantis. Each of those distributions is designed for a different audience with a different skill set in mind. Mirantis is obviously, they're your consulting organization. They're going to come in, they're going to do a professional services engagement, they're going to leave you with a working operational OpenStack environment that does exactly what you want it to. Ubuntu, on the other end, is the download it yourself and go at it. It's for organizations with either limited budget and or staff that are really comfortable with OpenStack and with Linux and are looking to implement something as quickly and cheaply as possible. And then Red Hat is in the middle. Red Hat obviously has a professional services org, but it's a very grown-up distribution of OpenStack. There's the same support model and same patching and satellite model that all of the Red Hat products have. And so for customers who have been using Red Hat or who've been using enterprise Linux for a while, the point being, use a distro to cover the weaknesses of your team. If what you don't have are knowledgeable people around OpenStack, but you have an important need to get OpenStack in production, then maybe looking at somebody like Mirantis would be smarter than pulling down the bits from Ubuntu and trying to do it yourself. So use those distros, understand what the companies have to offer, and use that to your advantage. This next one is a little tongue-in-cheek, but important. OpenStack is not a VMware replacement. It seriously isn't. There are workloads that don't have the ability to handle hardware failure, that don't have the ability to handle some of the things that OpenStack creates, where VMware absolutely does. That's, they've spent more time and money on a bunch of the hard things around how do I take monolithic legacy apps and protect them as much as I possibly can. So looking at OpenStack as a VMware replacement tends to get people in trouble pretty quickly. One of the things that we've seen customers talk a lot about is that we've gotten to a point where there's lots of OpenStack projects, right? There's the Def Core, right? There's the Nova Compute, there's Neutron, there's Cinder, right? There's Glance, there's Swift, there's kind of the core of what is OpenStack, and then there's all the rest of the stuff that sits around it. Think big, think about where you want OpenStack to be and the problems you want it to solve. Start small. Start with Def Core, start standing up the instances that you need, and then as you start to figure out how you're going to operate it or what sort of operational overhead you're willing to put on it, then start thinking about the extra projects and what you want to bring in and what you want to implement. If you try to bite off all of it at once, generally what we see is that customers get wound around the axle with one of the projects, and it ends up scrapping the entire OpenStack deployment when it didn't necessarily have to. These last two are just general things that we've seen. One is we get lots of customers who will roll out a beta or test dev and everything will go great, and they've got a small team of people who've been trained up on it and everything works the way it should, and then all of a sudden they turn around and put it into production and they just don't understand what happened. How did we get here? Why did this do things that I didn't expect it to do? Be very deliberate about moving things from one environment into the other, particularly with the storage side of things. You don't want to overrun it because that first implementation you put into production is going to set the bar for what your customers expect. And having that first deployment go poorly ends up making everybody's jobs harder. And then finally, what are you leaving for the next guy? OpenStack is one of those environments where people move around a lot. There are a lot of opportunities. There are a lot of positions that are available. If any of you have been to an OpenStack summit or an OpenStack meetup, the jobs board is usually pretty covered up. And so what we see is a lot of folks who will get in, will build the foundation of what it is that the company needs. They'll get trained up, they'll get a set of skills, and then they'll bounce and find another job. And from a community standpoint, we want everybody to have opportunities. From a professional standpoint, think about what you're leaving for the next guy. What's your legacy going to be with that customer? What's your legacy going to be at that company? Think about where it is that you want to be, but make sure that you take care of the people that you've committed to take care of in the process. So if you want to learn more, we've got a couple URLs here. We've got the OpenStack mini site there on the SolidFire. We've got the AI mini site where you can download all 4 of the Agile infrastructure designs. The 4th of which is being rolled out at VMworld here in a few weeks. And if you want to see it in action, we've got a great series of demos. We can do live demos where you actually get to configure Cinder, where you actually get to create QoS levels and retype Cinder volumes and all sorts of fun stuff. So if you want some hands-on there, reach out, request a demo, reach out to me on Twitter. I'm happy to help out where I can. And with that, we're going to move into our last polling question. So we're going to do this one pretty quick. We've got about 5 minutes left here in the presentation. Audience polling question number 4. When considering OpenStack as your cloud management platform, what criteria is most important to you? and this will just be a choose one. So if you want to go ahead and kick that one off, there we go. We'll give everybody just 1 minute here to put their votes in. What's most important to you? Are you looking at cost? Is it a TCO play? Is it a hardware integration play? I want my OpenStack to be as tightly integrated with the platform as possible, which is something we see a lot on the VMware side of things. Do I want the ability to deploy quickly or scale? Is it just, how quickly can I get it up and running? Is it performance, or is it security? I need to be able to deploy these workloads, but I have some pretty unique requirements around security and need to make sure that that's taken care of. All right, 2 more seconds. All right, we can go ahead and stop that one, Jen, and we will look at the results. Ability to deploy quickly. That's pretty consistently. Security has gotten bigger lately. Ability to deploy quickly is something that we see from many, many customers. And I think it's one of the reasons that the Agile Infrastructure reference designs have been as popular as they are. So it's good to see that continuing to be. The hardware integration, very interesting that that's so important on the VMware side, and just not nearly as interesting on the OpenStack side. I'm interested to figure out why that is. So from a SolidFire standpoint, our job is to power the world's most demanding data centers, right? We do that by being as innovative as we can. We think we've got the most complete all-flash array feature set on the market, whether that's the scale out, whether that's QoS, whether that's the system automation, whether that's inline efficiencies, whether that's lots of replication options, snapshot, near time, real time, being able to offer all of that in a single license, no features, no individual charges. We've proven it. We've proven it both from a company standpoint. We've also proven it through the Gartner Critical Capability Studies for 2 years running. And we've proven it with the growth that we've seen. So the company continues to grow. The company continues to drive more arrays into more places. The all-inclusive feature set is a big deal for us. People who license individual features drive me crazy. We try to stay away from that altogether. There is a grand total of 5 part numbers on the SolidFire side. There are 4 nodes, and then there's a support line item. So whether you need smaller capacity with higher performance, or whether you need higher capacity with extremely high performance, all of these building blocks are available to our customers to mix and match as they need to mix and match as they see fit into a cluster of whatever size makes sense for their environment. So if we can provide the best platform, if we can prove it every day with the most demanding customers in the world, if we can provide a feature set that is compelling and all-inclusive, and if we can deliver it on the building blocks that our customers are looking for, what we want everybody to be able to do is go do epic stuff. Whether that's OpenStack, whether that's VMware, whether that's both of them running together, being able to do that on top of SolidFire, being able to guarantee the performance for all of those workloads. We want the storage platform to stop being the boat anchor that drags down the agility of IT and make it something that lets you go forth and be a force of the awesome. So with that, we're going to go ahead and wrap it up. Jen has reminded that there are a couple of the attachments over on the attachment side of things that aren't working, but all of those assets are going to be emailed out to the attendees shortly. So I apologize for the issue there with the presentation side of things. We'll make sure that all of those attachments get sent out. The Prezzo slides are also available, and those are working in the attachments, so you can go ahead and get those now. And I'm available via email. It's just jeremiah.dooley@solidfire.com, or on Twitter. If there's anything that you need more information on, if there's any additional questions that you want to ask, I'll be happy to help out. And I don't see any questions in there, and it looks like we've got about 10 seconds left. So again, on behalf of both Jen and myself and all of SolidFire, we really appreciate you taking the time, and I hope you have a great rest of the week.